All right, so graphs and the unit circle, they kind of work together. So if I was solving this equation, sine of x equals 1/2, I can look at my sine graph and look where the y values are 1/2. So here's the line they were looking at, and it hits like again and again and again. It just keeps going. So what they're going to do is they're going to put pi6. I see that it hits at this one at pi6. And then they're adding 2 pi n. So like pi6 plus 2 pi, pi6 plus another 2 pi, like it's going to repeat. And it's going to hit that point over and over and over again. And then if my x is this other angle right here, 5 pi 6, then again, it's going to repeat every 2 pi. It's going to hit again and again. Even if I'm subtracting 2 pi, it's going to go again and again and again, every full circle. So you can do that off of the graph. I usually look at the unit circle on this. My sign on my unit circle are y values, and my y values here, they're the same y values. They're both a y value of 1/2. My sign equals 1/2. And it's happening like right here, this is at pi6. And then I could repeat the circle, like I can go 2 pi and I hit the same point, and then I can do another circle and go back to the same point. So like I can add 2 pi n, like add another circle and another circle and another circle, and I keep hitting the same point. Same thing for this other point with so 5 pi 6, that gives me a y value of 1/2. And I could just like add another 2 pi, like add a full circle, and I go there again. Add another 2 pi, and I land there again. I can add 2 pi and 4 pi and 6 pi. Every 2 pi that I add on, I just hit the same point over and over and over again. All right, so I'm going to kind of use that concept to solve these equations right here. So to solve for my x, I'm going to try to get my variables on the same side. First things first. All right, I'm going to divide by a -2 on both sides. All right, so -√2 over 2 equals my sine of x. And I think I know where on my unit circle, where my sine equals a -√2 over 2. Sine are the y values on my unit circle, so my negative y value should be down here. The -√2 over 2 is actually these points right here. They both have the same y value of -√2 over 2. You guys had to memorize your unit circles. This one would be at, let's see here, it's like pi plus pi fourths, so 5 pi fourths. This other one is 7 pi fourths in radians. All right, so both of those have the same y value, which means they have the same sign. Sign on my unit circle is a y value, which means I'm going to say that my x here, x is always an angle. I always plug in an angle into my sine function. And my x has to equal the 5 pi fourths, and then every like full circle after that. So plus the 2 pi n. So that was from this 5 pi fourths, and it happens then at the 7 pi fourths. And every full circle after that, so plus 2 pi. So I go again and again, every 2 pi, every full circle that I go, I keep landing on that same spot. All right, so this is how we're gonna write our answers. All right. And then number 2 here. Oh, Shire, did you hear what I was saying? So I was talking about, what did you guys miss? You guys at home, did you miss this? Where's this?
You were lagging quite a lot, and I think that's what she was talking about.
Oh, like the second half of it? Okay. Okay, good, okay. So I guess I'll just real quick tell you kind of what my layout was. I had to first solve for sine. I figured out sine is y values, so I figured out those y values on my unit circle, and then I made it repeat every 2 pi. Yeah.
You're trying to find like the base functions of every single one of them, and then just use that.
What do you mean by base
I
functions?
mean, like just sine, tangent. just
Yeah,
random
yeah,
ones.
I'm solving for one of my trig functions.
Yeah.
I don't want to solve for 2 different ones. This one I just solved for sine. This one I'm going to solve for tangents. This one this one I have number 3. I've got a cotangent and a cosine. So I'm probably gonna have to use those identities. Remember you guys were doing the last couple of days, you were using identities to kind of transfer and make things look a little different. So if they give you 2 different trig functions, I would probably use my identities to make it look like a single trig function. But yeah, I'm trying to solve for one of these trig functions. All right, you guys at home, is this okay at all? Are we okay on number 1? It's not even letting me open this. Yeah, I think so. It's not letting me open the chat at all. So if you guys, yeah, just turn on their speaker. Let me know what you need. All right, so if we're good at number 1, I'm going to go on to number 2. Number 2 is very similar. So let's see if we can compare these. Number 2, I still, instead of getting sine by itself, I want to get my tangent by itself. So I will add the 1 on both sides. Divide by 3 on both sides. And I will take a square root on both sides. All right, whenever I take a square root, I get a plus or minus. I've got a positive and a negative. Square root of 1/3. Now let's see, the square root of 1 is 1. The square root of 3, I don't know the square root of 3. Let's leave it root 3. All right, but I have a plus or minus. We did have to memorize our unit circle. I'm thinking, since tangent is sine over cosine, I think this comes from the point when let's see, should it be a 1/2 and then a root 3 over 2? Should it be like that? Or should it be a root 3 over 2 and then 1/2? Which one, if I do the sine over cosine, like the y over the x, which one is going to divide out and give me this?
The bottom one.
Bottom one. Okay, so let's try it out. The sine, like the y, over the cosine, the x. Okay, so this one, if I multiply by the reciprocal, those are gone. It gives me a 1 over root 3. Nice, 1 over root 3. So I would kind of look for these types of points on my unit circle. Root 3 over 2 for my x value and a 1/2 for my y value, which, let's see, on the unit circle, let's see, that would be like this point right here. There's a 1/2 root 3 over 2. Okay. Oh, we were going for a root 3 over 2 and then a 1/2, right? So just kidding. We were going for this guy down here. There's my root 3 over 2 and then 1/2. There we go. And then, okay. This had a plus or minus. So I think over here, when I have a negative root 3 over 2 and a positive 1/2, I think those would divide out to give me a negative 1 over root 3. So that's fine. Positives and negatives both count. In fact, that means I'm going to have 4 different places where this happens. Yeah.
Wouldn't it be 1/2? No, it wouldn't, because it's a tangent.
It's a tangent, so it's sine over cosine. Yeah.
Yeah.
Sine over cosine, like the y value over the x value, which, yeah, that gives me a 1 over root 3 right there. Nice. Okay, so I have 2 of them so far, but I think there's actually 4 options here. This one also gives me a negative root 3 over 2 and then a negative 1/2, but negative divided by negative is positive, and that's okay. I can have a positive 1 over root 3. I can have positives or negatives. So then this last one right here, root 3 over 2 and a negative 1/2, that would be like a negative divided by positive is negative. So I'd get a negative 1 over root 3, which still counts positives and negatives. So I actually have 4 different points let's see if we know the angles for those points. The angles for these points are at, let's see, this one's pi 6. This one right here, that is pi 6 short of pi. So instead of like 6 over 6, this is going to be 5 over 6, 5 pi 6. All right, and this is pi 6 past pi. So past 6 pi 6, I go up by 1 to 7 pi 6. All right, and this one over here, this is pi 6 short of a full circle, short of 2 pi. So let's see, 2 pi 6, isn't 12/6 the number 2? So I'm going 1 short of that. I'm going at 11 pi 6. Okay. So here's what I'm thinking. Put this in the color. These guys right here, those are like half a circle away from each other. They're right on the opposite side of the unit circle. They're half a circle away from each other. And if I go a half a circle again, I get back to the other one. I go a half circle, get back to the other one. My point on that is I'm going to probably say that my x equals this pi 6 plus every, not 2 pi, but every 1 pi times n. So like if I add 1 pi, that gets me to the 7 pi 6, and that counted. If I add another pi, it gets me back to where I started. So I actually have covered 2 of those points with just this one equation. I covered 2 of those points. And then if I get one of the others, so maybe I'll start at the 5 pi 6 here. At 5 pi 6, I could say 5 pi 6 and then add 2 pi, like go full circle, but that kind of skips. I think I'm going to go 5 pi 6 plus every pi, so plus pi times n. Again, because if I add 1 pi, if I go half a circle, I land on another solution. And if I add another pi, I land on another solution. Every pi, like every half circle, I get to another solution. So that's why I would do 5, 6 plus pi n. So that actually covered all 4 points. So here's my answer.
You do not need x equals 7 pi 6.
Okay, so the 7 pi 6 is actually already taken care of because of the pi 6. Yep. If I go half a circle from the pi 6, if I go half a circle, that lands me at 7 pi 6. Half a circle being pi that we were talking about. If I add pi, I end up at the 7 pi 6. Okay. If you really wanted to, you could do the pi 6 plus a full circle plus 2 pi n, and I could do the 5 pi 6 plus a full circle 2 pi n, and I could do the 7 pi 6. I could do all 4 of these plus a full circle, but that's probably not the simplified version. That's not the simplified version because I really could narrow it down. Instead of doing each of those 4 points and a full circle after each of those 4 points, I could narrow it down into only 2 of the points every half a circle. Okay, so that's why they're probably not going to write it like that. All right. So now let's see if we can do the next one. This is the one I was telling you. I probably want to get to all a single trig function. So let's see if we can use some of our identities that we've been messing with here. All right, I'm gonna get all of this on the same side first.
Ms. J.
Oops. Cotangent of x times my cosine squared of x. I'm going to subtract the 2 cotangent of x. I'm going to subtract that over, make it all equal 0. Maybe I don't even need identities, actually. Let's see here. What I'm thinking is a greatest common factor, what they have in common. It looks like they both have a cotangent in common. Let me factor out a cotangent of x.
Miss Jang, you're frozen.
So I factored out my cotangent, and actually, I think I don't need to use identities on this because I can set my factors equal to 0. And I think you guys have done this with a lot of algebra before. You set your factors equal to 0. These are like trig in each factor, but the same rule applies. I can set my factors equal to 0. So I can do my, oh my goodness. Of course. All right, there we go. Okay, so I'm going to take my first factor here, my cotangent of x. I'll put that equal to 0. And I'll take my next factor, cosine squared minus 2. I'll set that equal to 0. All right. So cotangent, on my unit circle, tangent, we just talked about up here, tangent was like the y over x. My cotangent is the reciprocal. Cotangent is the x over y on my unit circle. So on my unit circle here, if I'm talking x over y, I'm thinking I want the x to be 0. I don't want to divide by 0. I want the numerator to be 0 to equal this 0 right here. So my x values on the unit circle are 0 up here. Put this color coordinate this here. This is the point 0, 1. Down here, this is the point 0, negative 1, but both of those x values are 0. So I think this is going to give me the angles. I could repeat them all, but I think really this is just a half circle. I could start at one of them and go plus pi, plus pi, plus pi over and over and over again. So I think I'll go from this angle right here, which was pi halves radians. If you want to do degrees, if it's like 90 degrees. Pi halves radians plus every half a circle. So every pi times n. All right, so that solved my first factor. I need to solve the next one. This one I got a little work to do. I need to add the 2 over, and I need to take a square root. Plus or minus when I do my square root. Except for, did anybody put the square root of 2 in the calculator? What is, it's probably a messy decimal, but what is it? What messy decimal do you guys get?
Uh, 1.41.
1.4, but it's more than 1 though?
It's more than that. Well,
No, but is it more than 1?
yeah.
It is more than 1. And the reason I'm pointing that out, it can't be on my unit circle if it's more than 1. My, 1 unit, this has a radius of 1 unit. I can't have any, cosine is an x value on my unit circle. I can never have some x value past, this is my 1. If I had an x value past 1, it would be like over here. It's not on the unit circle. So for that reason, I actually have no solution from this factor. The only final solution that I had was the cotangent of x. That gave me a solution, but that was it. And you can probably tell if you tried to do cosine inverse of root 2 in your calculator, it probably says like error or something like that. Okay. So we've gotten through 3 of these problems. You guys have questions on any of these 3 before I move on?
Miss Jang, you're frozen.
As in, like,
it
the
home?
screen's frozen for you, or like she can't hear us?
I just heard somebody
Oh, now you can. Cool.
come over the speaker. Do you have any questions?
You were frozen.
I can't open the chat box though, so if you guys are typing questions for some reason, I can't see it. You guys can just turn on the speaker though if you have them and let me know.
Jang, someone's saying that your screen has been frozen for a little bit, and I don't think you can hear us half the time.
Oh, so the screen, can you guys see what's on the screen?
I can see what's on the screen, but another person
Other people.
cannot.
I can
Okay.
see what's on the screen. I just can't. I couldn't hear you for a while, and whatever you were writing wasn't showing up.
Oh,
Okay. I'll tell you what, guys, I'm recording this, so I'll post it probably by the end of the day. So you guys are welcome to go back and look at whatever it was you couldn't catch. Does that work for you guys?
Yeah, thank you.
All right, sounds good. I'm gonna
I
try
had
to
a
finish.
question.
Yeah.
Why did you make both of the like functions equal 0?
So I made them each equal to 0 because this is what I do with factors, like algebraically anyway. If I had like x minus 2 and then x plus 1 all equals 0, I would set each of my factors equal to 0. This is how I usually solve my factored equation, right? So I would get like a 2 and a 1. That's pretty much what I was doing here. It was just more complicated factors. They were trig factors, but other than that, the same concept is what I was going with. Does that clarify at all?
You cut out a lot during that, but I'll watch the video later.
Okay. I'm sorry, you guys. I wish I could fix that. All right, I'm just gonna move forward then. So for number 4, it says find all solutions of this equation in the interval 0 to 2 pi. So I think what's different here is you are finding solutions just between 0 and 2 pi. So like, just if you go around the unit circle once, that's it. You're not going to put like every 2 pi after that. Okay, so I do see all signs on this one, which is a good thing. I'm going to pretty much do kind of what I did up here. You know how I factored this one? I'm going to factor number 4 as well. All right. Let's see. What multiplies to be -2 and adds up to a -1? You guys think -2, +1? So I'm doing factor by grouping right now, which this is what I would do if they were just plain x's. I'm doing it with the entire sine of x. I'm treating the entire sine of x as one of my x's. But let's see, if I do my factor by grouping, this first group right here, what they have in common is, let's see, a 2 and a sine. And I'm left with the sine of x minus 1. All right, so I did my GCF, my greatest common factor in the first group. The second group, I don't really think they have anything in common. I guess I could factor out a +1, but that's pretty much it. So I'm left with sine of x minus 1. All right, so now the GCF, the greatest common factor, it looks like they have this sine of x minus 1 in common. So I will factor out the sine of x minus 1, and I'm left with 2 sine of x plus 1. All right, so this is where I was on number 3 here. I got it all factored, and then I set my factors equal to 0. So my first factor, my sine of x minus 1. I'm going to set that equal to 0. If I add 1 to the other side, my sine of x is going to equal a +1. Which that I do think is on my unit circle. Let's see where that's on my unit circle. That would be sine are the y values. So my y value is a +1 up here. I think that's the only spot on my unit circle where the y value is +1. That's at pi halves. I needed it between 0 and 2 pi, so I'm going with the positive pi halves. I'm not going to repeat it over and over again. Just sticking between the 0 and 2 pi. I think that's the only spot here. So just for this particular one, x equals pi halves. Now my other factor, let's look at the other factor. I will set this equal to 0 again. So I will subtract 1 on both sides, divide by 2 on both sides. So my sign has to be a -1/2. So -1/2, all my negative y values are down here, sign's a y value. So my y value would be a -1/2 down here. In fact, here are my 2 points with the same y value of -1/2. All right, so Audrey, I made my factors equal to 0 because 0 times whatever equals 0. So I do with factors a lot. So this one was at, let's see, this is pi6 past half a circle, past pi. So I'm going to treat my half a circle, I'm going to treat it as 6 pi6 plus another pi6. This gets to 7 pi6. And then this one is pi6 short of a full circle, which a full circle is 2 pi. 2 pi in terms of 6, I think 12 pi6 is a full circle, and I'm one short of that. I'm at 11 pi6. All right, so I have 2 spots for this. My x in this case is a 7 pi6 and an 11 pi6. And I just wanted the ones between 0 and 2 pi. I'm not going to repeat it. I'm not going to put plus, 2 pi n or anything like that. I'm not going to repeat it. These are my final answers. I've got 1, 2, 3 angles as my final answer. So on your homework, I think they'll make you list your answers. You would have to list all 3 of these. Okay. And then one more here. Number 5, I have to solve this equation problem though.
Q, sine, cosine.
I've got a sine and then I've got a cosine. The stuff up here on number 4, I factored it and everything, but it was all sines on number 4. They all had the same trig function. So if I'm trying to factor this, I'll get it in there one more time. Come on. All right. So yeah, instead of having both the same trig function, I have 2 separate trig functions now. Let's use our identities. Like sine squared, that kind of triggers in my mind the identity sine squared plus cosine squared equals 1. So I'm going to do some work off to the side here. Off that identity, I'm going to solve for sine squared. So I'll like subtract cosine squared to the other side. All right, so I'm going to put this in for the sine squared. So I've got, the rest of this is the same. I still have the 2, and I still have this plus 3 times cosine x and the minus 3. It all equals 0. Good, good. I'm just replacing the sine squared with what it's equal to, a 1 minus cosine squared. So now I got all cosines. Let's see if we can simplify this down a little though. I'm going to distribute my 2. Come on, you can do it. Dang it. Let's see if this is working. Okay, I distributed my 2. And I think I can simplify a little more. I can combine my positive 2 and my negative 3. So let's say 2 minus 3 is a negative 1. Okay. So at this point, I'm kind of where I was on the last one. I can factor it so my factor is equal to 0. Do you guys know how to factor this particular problem? Or would you rather use the quadratic formula? Those are pretty much your 2 options. Would you rather factor or use the quadratic formula?
Factor.
Factor, okay. So if I was going to use the quadratic formula, I'm treating my cosine like my variable. So you can do this if you want to kind of simplify it down. It's a few extra steps, but it could be helpful. You can kind of make your cosine of x be another variable. So like pick another letter, I don't care. Z, okay. So if I did that, I would have like a z squared, negative 2 in front. I'd have a 3z minus 1 equals 0. So if that makes it easier for you to see like how to factor it and everything, you can do that. I just replaced all of my cosines with a z. So instead of cosine squared, I had z squared. Instead of 3 times cosine, I had 3 times z. So if that's better for you, go for it. But again, my question to myself was still, do I want to do the quadratic formula on this to solve for the z, for the cosine? Or would I prefer to factor it? Does anybody actually figure out how to factor this one? Yeah? What do we get? Factor by grouping. Okay, so then if you factor by grouping, you have to break that middle part into 2 pieces. What would you break that 3z into? A z and a 2z. So if I do that, then the other one's this negative 2z squared is still there. My negative 1 is still there, but I would group the first 2 together, group the last 2 terms together, also equals 0. Okay. And it's all about this GCF, the greatest common factor. And in that first group, I think I can factor out a z. I still have a negative 2z plus 1. And then this one, I think I would factor out a negative 1 because I want it to match this other factor that I had. I would factor out a negative 1, basically change the signs into a negative 2z and a positive 1. All right. Yeah, you guys had good ideas. And now again, GCF, greatest common factor. They have in common a negative 2z plus 1. That's kind of why we factored it the way we did. We wanted it to match. So now I factor out this 2z plus 1, and my leftovers are the z and the minus 1. So there's my z minus 1. All right, so we've got our factors, which you can set your factors equal to 0. But keep in mind what my z is representing for me. My z is a cosine of x. So this is pretty much telling me, I'll turn this into cosine again. This is telling me negative 2 cosine of x plus 1 equals 0 instead of my negative 2z plus 1 equals 0. So I will subtract 1 on both sides, divide by 2 on both sides. All right, so my cosine is supposed to be a 1/2, which on my unit circle, let's see here, cosine is a cosine are my x's, so I need a positive 1/2 x value. And there's 2 spots where that happens. All right, I'm hoping we have our unit circle memorized. These 2 angles were at pi thirds. All right. This was 5 pi thirds. All right, so my x equals, let's see, am I going to be able to repeat this one every 2 pi, or is this one restricted to only within one circle? let's see, the stuff I had highlighted up here on number 4, that highlighted part from 0 to 2 pi, like restricting me to one circle. I don't have that on number 5. I was not restricted to one circle. So I think I'll have it repeat over and over again. This will be my x equals pi thirds, and then another full circle, so plus 2 pi gets me back there, plus 2 pi gets me back there. I'm gonna add 2 pi times n. I did not add 1 pi. 1 pi is like half a circle. If I went half a circle, I would have ended over here. That was not where one of my solutions was. So I didn't do 1 pi, I added 2 pi. And then I'm gonna do the same thing for my 5 pi thirds. I'm gonna add every full circle, 2 pi times n. All right, so that was from this first factor that we set equal to 0. My second factor that I'm setting equal to 0, this is the z plus 1. So I'm going to set z plus 1 equals 0, z being a cosine of x. So it's like my cosine of x plus 1 equals 0. All right, so if I subtract the 1 over, and on my unit circle, cosine are x values every time, and cosine is a -1. My x value is a -1 over here at pi radians. And there's just that one spot on my unit circle.
Isn't it
And-
-1, not +1?
Oh my goodness, thank you. Yeah, so you're talking about right here. I somehow wrote a z plus 1.
Yeah.
Gotcha, thank you. Okay, got it, got it. So that's gonna change this. It's gonna be a cosine -1, which means I add the 1 over to the other side. All right, all right. So let's adjust this here. My cosine is a +1. My x value is a +1 right here at, you can say either 0 radians, you could say 2 pi, like a full circle. I'll just call it 0. And then every 2 pi after that, so plus 2 pi n. I don't really need to add 0 though. I'll just say x equals 2 pi times n. 2 pi times 1 would be 2 pi. 2 pi times 2, 4 pi. It's like 2 pi times whatever whole number is going to land me at another solution. So again, on your homework, you're going to need to list all of these solutions, which it looks like there are 1, 2, 3 that you would have to make listed. All right. So that was our last problem for today. And those of you guys at home, I'm going to try to post this as quickly as I can so you can kind of look at it and clarify whatever you need help with.